So combinations. First we'll talk about, kind of what they mean. As it says at the top of your notes and not necessarily on the smartboard, in permutations, if I switch two objects around, is that a different arrangement in permutations? Yeah, it's a different arrangement. When you do a combination, I'm not arranging things, I'm combining them. Okay? And so for the textbook problems, we had, well, if I put one book on the shelf and then another one, but then I switched the position, that counted as another option, right? That counted as two options. Well, here in a combination, that just means you have two books on the shelf. Good for you. There's just one way to do it. You put the two books up there and you're done, right? And those are the two you picked. No big deal. And so that's why a lot of times you can say that really, according to these terms, you have a locker permutation. You have to put those numbers in your locker com the right way. It's not really a combination according to these words. Okay? Does combination have other meanings? Of course it does. But in math, you have a locker permutation and not a combination. So here it says to just take however many objects you have, n factorial, divide by n minus r factorial. Do you see? That's basically the same formula for permutation. But here it has an extra r factorial that you're dividing out. What that does is it divides out all those ones that are extra ways of jumbling the same things. Okay? So do you expect these numbers overall to be bigger or smaller than the ones that we had before? Smaller because, again, I'm not counting as two things being different as a different permutation, and you're dividing by something more. So you're telling me that 5c2 is going to be smaller than 5p2? Yeah, it's going to be considerably smaller. So let's go ahead and let's do one by hand. So this is n right here, and that's r right there. So let's do this by hand. So it's 5 factorial over 5 minus 2 factorial, and then what? According to the formula. 2 factorial. Okay. So we basically have 5 factorial on top, and then 3 factorial, 2 factorial on the bottom, correct? Everybody see where that comes from? So if I were to write it out, it's 5 times 4 times 3 times 2 times 1. And you don't have to write it out if you understand how factorials cancel. This is 3 times 2 times 1 times 2 times 1, right? That's really what it's saying, all in all. So that 3 cancels with that one. That 2 cancels with that one. That 1 cancels with that one. And this 2 becomes a 1, and that 4 becomes a 2. And that's just a 1 at the bottom, so that's good. And so we take 5 times 2 over 1 times 1. Well, 5 times 2 is 10. Over 1 times 1 is 1. So how many, if I had 5 things, how many ways could I combine 2 of them? 10 ways. But that means that, let's say that there were 5 students and I was going to choose 2 of them. That means if I pick Ian and then Alex, and then I turn around and do it again and I do Alex and then Ian, I picked the same group, right? That doesn't count as different, just because I did it in a different order. Okay? So 8, choose 5. And then once we do this one by hand, I'll show you how to do it on the calculator, and then I'll see if you can do the last one on your calculator. So it's 8 factorial over 8 minus 5 factorial and 5 factorial, correct? So in other words, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 8 minus 5 is 3, so that's 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. I'm hoping you don't have to write it out every time, right? Hopefully you're starting to get used to how this cancels. So in other words, right? And then this is basically 6, right? So the answer is 56. So that's if I had 8 objects and I would like to kind of, for C, I normally say choose. Choose 5 of them, or have 5, or combinations of 5. How many combinations of 5 do I have? 56. So let's do 8 choose 5 on the calculator, and then I'll let you do 8 choose 3 also on the calculator. So there it is. So on these, on the 84s or the 83s, you have to type the 8 in first. Okay, so you type in 8. And then you go and get the NCR button. That's actually what it looks like. And so you go to Math, over to PRB, and NCR is the third one down. Okay. There it is. And so I'm telling it I have 8 objects. I would like to choose 5 of them, and hopefully we get 56, right? If not, we're a little suspicious. There it is. Now, that's a lot of buttons to hit, right? So let me show you a quick way of kind of redoing this. Because you have to do what? 8 choose 3. So a quick way is, especially on these, on the 83s or the 84s, is if you hit the second button and then enter, it brings back the last thing you typed in. So hit second, enter, there's the last thing I typed in, and it lets me go back and change things. So then you don't have to keep going and getting that NCR button. And so the only thing I have to do is go back and change that to a 3. So why don't you go ahead and do that and see what you get. Take a second or two. Those with the TI 32Ss or whatever those things are called, it's just under the PRB button that you have to find that. And some of the other calculators, I would have to find it, those of you that have different ones. Is it on there? Are you suspicious of your answer? Are you just going to trust the calculator, or are you going to try and make some kind of reasoning for why this actually works? So as you can see, whoops. B and C are both 56. Okay, yeah, if you write it out by hand, it does all cancel pretty much the same way, right? But can you give me an explanation, not mathematical, as to why they would come out the same? Yeah. Okay, so what was said is that it really boils down, if you put it into the formula, the numbers do work out, that it's basically the same math. Okay, so that's a very good mathematical explanation as to why they are both 56. But how about non-mathematical? No formula, anything behind it. So look at it this way. If there's 8 things and I want to choose 5 of them, how many am I not choosing? So could this one letter B say 8, choose 5? Or in other words, couldn't you also say 8 and don't choose 3? So this one is saying 8, choose 3, but you could say just do 8 and don't choose 5. So do you see how they're the same thing? Okay. So let me give you another example that, or have you finish off an example that should be the same. For example, if I give you 9, choose 4, that better be equal to what other option, if we stay with the 9? 9, choose 5, right? Those better be the same, because this only works for combinations, though don't try that with a permutation, right? So here it's basically saying 9, choose 4, or in other words, don't choose 5. So you see how they're really the same thing. It's how many ways you can or cannot do something. And so they should end up the same. So if I give you a question like that, I may very well, do something like this and say, tell me what x has to be. And based on this problem, you should be able to do that. What would make those two equal? The only x value that should make them equal, in this case, would be 9. Okay? So keep that in mind. So here's one possible way that you could look at this. For the math team, I'm going to pick 12 people. I'm going to select those 12 students from 20. So there's 20 possibilities. I would like to choose 12. How many ways can I select those 12 students? I'm assuming I'm just going to go out there and I'm just going to pick 12. So I'm not going to say that the first person I pick, you're the best math student, and then the second one, you're the second best. I'm just going to pick 12. In other words, how many ways can I pick a team? So how many students do I have? I have 20 total students. I would like to choose 12. The reason it is a combination is because of the way I said it. I said I'm just going to choose 12. They make up my team. Does it matter if I go player 1, player 2, player 3, or player 1, player 2, player 3? No, it does not matter. I still have my team. Okay. You could look at it this way: there's no intrinsic value placed on when I pick you. Okay. So do 20 choose 12, and tell me how many ways I can pick my team. I heard something. Yeah. Yep, 125,970. You a little surprised by that number? I am initially, until I compare it to 20p12, which is somewhere in the 6 trillion range. Okay, And so then, oh yeah, that makes much more sense then, right? Because I actually did 20p12, and it is, you know, in scientific notation, I think. So it's about 6 trillion ways I could do that. So here, then it does make sense. Okay. So here we go. We have a bag, and in there we have 4 acorn squash, 5 gourds, and 8 pumpkins. How many ways can 2 acorns, there should be a comma there, 1 gourd and 2 pumpkins be chosen? Do I care which one comes first, according to this? Do I have to pick one first, and then this one, then that one? No. Just saying, how many ways could I do it? All right. And so the order really does not matter, which leads me to combinations. So so we're looking for acorns here. How many we got? We got 4. So there's 4 of them. How many ways can I choose 2 of them? That would be how many ways I could kind of pick that out of there. And then the next one is 5 choose 1. I hope you kind of know that one, but if not, we'll talk about that, what 5 choose 1 is. I hope that isn't too hard. And then 8 choose 2. Do you see, because a lot of people think that once we get past 12-1, that the counting principle isn't important anymore, but it still is. Do you see how these are kind of your blanks that you're filling in? We're just filling them in a little bit more complicated way. All right, it's taken us a little bit more to do that. So 4 choose 2. So we're saying there's 4 things there. I can pick these 2, or I can pick those 2, or I can pick those 2. How many ways can you do that? And maybe think in your head, how many ways could I do that? If I had 4, I could pick these 2, or I could pick those 2, or I could pick those 2, or I could pick those 2. Those 2 are those 2. So how many ways can you do it? If you actually look at something in your mind, it actually does come out to be 6. Okay. If I had 5 things, so this is really going to tell if you understand what a combination is. If I have 5 things sitting on my desk and I want to choose one of them, how many ways can I do that? 5. Either I pick the first one, the second one, the third one, the fourth one, or the 5th one. Right? There's only 5 ways you can do that. 8 choose 2 is a little bit more complicated because you have a lot more, groupings, right? So 8 choose 2 is 28. So is the answer 6,528? No, I have been told in the past that is what the answer is. But remember, this is basically going back to counting principle. Those are your blanks. They have 6 choices, and 5 possibilities, 28 possibilities. And so you go ahead and you multiply, and it's only 840. Is there any need to divide by 2? For example, is this a reflection or anything like that? No, it's not even circular, right? So don't even consider that if it's not circular, okay, or a permutation. So any questions so far? Okay. Example 4, I will probably not record because each year is going to have different answers, and so you should be there for